All right, let's dive right in. Today, we're going to talk about something absolutely incredible, something vital to your very existence. I'm talking about your immune system.
Okay, just picture this for a second. What if your body, what if it was a fortress? And I mean a fortress under constant, non-stop attack. We're talking millions of tiny invaders every single day trying to breach the walls.
Well, here's the wild part. It is. That's not some far-out concept, that's just reality. And the only thing standing guard, the only thing keeping you safe, is your immune system. Think of it as this incredibly sophisticated, multi-layered army. So you ready? Let's meet the soldiers.
Okay, so before we get to the individual soldiers, we got to understand the big picture, right? The grand strategy for defending the whole fortress. And in the world of biology, this is what we call host defense.
So, what is host defense? It's really just the name for the whole collection of tricks and tools your body uses to protect itself from pathogens. You know, those microscopic invaders we were just talking about. The goal is super simple. Don't let them in.
All right, check this out. Our fortress army, it's not just one big mob. It's split into two totally different divisions. First up, you've got your nonspecific or innate immunity. These are your frontline guards. They're fast, they attack anything that looks suspicious, but they have zero memory. Then you have the other side, the specific or adaptive system. These are your special forces. They're a bit slower the first time they meet an enemy, but they are laser-focused on one particular bad guy. And the most important part, they never ever forget.
So, where does any good defense start? With the walls, of course. This is our first line of defense. The big, heavy-duty barriers designed to stop trouble before it even starts.
And these walls are seriously impressive. You've got the obvious physical barriers, right? Your skin, mucous membranes, they're like the high stone walls of the castle. Then you've got these awesome expulsion traps. I'm talking about things like urination and defecation that literally just eject the enemy. And to top it all off, we've got chemical warfare. Things like the acid in your stomach or special enzymes in your tears create this deadly moat that just dissolves invaders on contact. It's pretty hardcore.
And get this, it's not just about keeping things out. Inside the fortress walls, you've actually got friendly villagers helping out. I'm talking about the normal, good bacteria in your gut. They're not just hanging out, they actively fight off new invaders. It's a process called microbial antagonism, and it makes them a super important part of the defense team.
Okay, but what happens if something does get through? You know, a breach in the wall. Well, that's when this second line of defense kicks into high gear. Say hello to the inner guard patrol. These are the cells constantly roaming the inside of the fortress, just looking for trouble.
So let's meet the crew. First up, neutrophils. These are your foot soldiers, the first responders. They rush to the scene, fight like crazy, and, well, they usually die in the process. All that stuff we call pus, that's basically just piles of heroic, dead neutrophils. Then you've got the big guys, the macrophages. Think of them as the heavy-duty security guards. They're huge, and they basically just eat anything they don't recognize. And for the really big invaders, like, say, a giant parasitic worm, you gotta call in the specialists, the eosinophils.
So, how does one of these guard cells actually eat an invader? The whole process is called phagocytosis, and it's kind of like a 5-step takedown. First, it spots the bad guy. Then it wraps around it, pulling it inside into a little bubble. That bubble then merges with another bubble that's just full of digestive enzymes. It's like a little stomach. The enzymes just dissolve the invader into harmless bits. And finally, the cell just spits out the leftovers. Job done.
Now, if there's a fight going on, you can't keep it a secret, right? The whole fortress needs to know. That's where the kingdom-wide alarms come in. You've got inflammation, you know the signs, right? Redness, heat, swelling, pain. That's like the local town alarm bell ringing, drawing all the guards to one spot. A fever, that's way more intense. It's a scorched earth tactic. The whole kingdom raises the temperature to make it miserable for the invaders and help our own troops work faster. And then you have backup systems like defensive proteins called interferons that act like warning calls between cells.
But what happens when the inner guard is just overwhelmed? What if they're up against an enemy they've never seen before? Something really powerful? Well, that's when you call in the big guns. The third line of defense, the elite special forces.
And what makes these guys so elite? They have two superpowers, basically. First, specificity. They don't just attack randomly, oh no. They are trained to recognize and hunt down one specific enemy, which they identify by its unique uniform called an antigen. And their second superpower, memory. They never forget a face. If that same bad guy ever comes back, the response will be so fast and so brutal you probably won't even feel a thing.
So what kind of weapons are these special forces using? They're called antibodies, and it's not a one-size-fits-all weapon. Check out this arsenal. You've got IgG, we can call that one the veteran. It's the main weapon for a repeat attack. Then there's IgM, the first responder. It's the first one on the scene for a brand new invasion. IgA is the gatekeeper. You find it in places like mucus and saliva, guarding the entrances. IgE is kind of the alarmist. It's what triggers allergies. And IgD is like the B-cell captain, helping to get the whole attack organized. It's an amazing, specialized toolkit.
Yeah, but an arsenal like this, a team of special forces this good, they don't just appear out of nowhere. They have to be trained. And that whole idea of training, that's the secret behind how immunization works.
Turns out there are pretty much two ways to get these skills. The first is active immunity. Think of this as boot camp. Your body actually sees the enemy, either from getting sick or from a vaccine, and it learns to make its own antibodies and memory cells. This is the good stuff. It's long-term. The other way is passive immunity. This is more like hiring a borrowed bodyguard. You're just given the antibodies, maybe from your mom when you're a baby or through an injection. It works, but it's temporary because your own army never actually learned the lesson. And this is where you can really see the difference that training makes. Look at the primary response. This is the first time your army has ever seen this particular invader. It's a scramble. The response is slower, they're still figuring things out, you'll probably feel sick. But then, look at the secondary response. This is what happens when that invader comes back. The memory cells spot it instantly, and the counterattack is faster, it's stronger, it's 100 times more effective. Symptoms barely even have a chance to show up.
Okay, now this visual really drives the point home. Look at the bar for the first invasion. That's the number of antibodies, the number of weapons your body makes. It's okay, right? A decent response. But now look at the second bar. For the repeat invasion, it's huge. It's not just a little better, it's an overwhelmingly massive response. This right here is why immunological memory is so unbelievably powerful. So this system sounds pretty perfect, right? Well, not always. No army is flawless, and sometimes this amazing defense system can make mistakes, big ones. And that's when you get things like allergies or autoimmune disorders. Let's start with hypersensitivity, which you probably know better as an allergy. It's basically a massive overreaction. The fortress analogy is perfect here. Imagine your guards see a totally harmless delivery person with some pollen, and they respond by launching a full-scale military assault. The weapons are real, the attack is real, but the threat was never there to begin with. And it turns out this kind of friendly fire comes in 4 main flavors. Type I is that immediate one we all think of, like hay fever, driven by IgE. Types 2 and 3 are a bit different, involving other antibodies attacking your own cells or clumping up where they shouldn't. And type 4 is the slow one, the delayed reaction, like that awful rash you get from poison ivy. And this timeline is super helpful because it shows you why these reactions feel so different. A type 1 reaction, we're talking minutes. It's almost instant. But a type 4, that can take 2 or 3 days to fully show up. And that explains everything, right? It's why a bee sting swells up right away, but the rash from poison ivy seems to creep up on you long after you've left the woods. So at the end of the day, our immune system is this absolutely brilliant fortress, defended by a complex and powerful army. But it's not perfect. It can be fooled, it can overreact, it can even turn on itself. Which kind of leaves us with one big final question to think about, right? What's next? What's the next great frontier in harnessing and training this internal army to help it defend us even better?